Okay, so what are we looking at here? Well, as the title says, we're looking at a rational function, and the objective of this video is to go ahead and sketch this particular rational function. This is kind of in line for those of you that are going to be taking algebra or currently taking algebra, but most likely probably like an algebra 2 or maybe a pre-calculus course. You really get heavy duty into rational functions. You start learning about rational functions early on, and then you kind of progress into how to deal, add and subtract, multiply, divide, solve rational equations. But graphing a rational function, well, this involves something called asymptotes. And we're going to need to really do a decent amount of work to get a fair sketch of this. Now, again, I'm going to emphasize this word sketch. It doesn't have to be a perfect graph. You know, most teachers and most homework problems are going to just have you just sketch something out, but you just still want to be as accurate as possible. But what I want to do here is really cover the mechanics on how to deal with rational functions in terms of their graphs. And so if you're new to this, well, stick around for a couple minutes. You're definitely going to learn how to graph rational functions. But again, this is going to be applicable to those of you out there that are probably this level of math, algebra 2, pre-calculus, college algebra, intermediate algebra, whatever. So we're going to get into this in just one second. But first, let me quickly introduce myself. My name is John. I'm the founder of TabletClass Math. I'm also a middle and high school math teacher. And over several years, I've constructed what I like to believe is one of the best online math help programs there is. That's a pretty bold statement. Of course, I'll let you be the judge of that. If you're interested, you can check out my math help program by following the link in the description of this video. But basically, I have 100 plus different math courses ranging from pre-algebra, algebra 1, geometry, algebra 2, pre-calculus, and I have many courses in the area of test preparation. So if you're studying for the GED, SAT, ACT, GRE, GMAT, ASVAB, AccuPlacer, ALEX exam, CLEP exam, maybe a teacher certification exam, maybe a nursing school entrance exam, maybe a high school EOC exam. There's a ton of different exams that people have to take. Guess what they all have in common? Math. So someone out there thinks math is pretty important. And if you don't do well in the math section, you don't do well on these exams. So let me help you prepare. Just go to my site, check out my full course catalog. If I don't have your exam, drop me a line and I'll help you out the best I can. I also do a lot of work with homeschoolers. So if you homeschool, I have a great homeschool learning program. And then obviously I help those of you that are having a tough time in your current math courses. Now, if you truly want to do well in math, okay, if you're serious about this, now if you're not that serious, just disregard what I'm going to say. But if you are serious, then you got to be serious about your note taking, okay? So I've been teaching math for decades, and the one thing I could point to with consistency is those students who take excellent notes. I mean, every single day they're paying attention to the teacher, they're writing everything down, their notes look amazing. They're like, better than, a textbook. That's what I'm talking about. That's what excellent notes are. Well, these students always do very, very well who have those type of notes because it's a lot of work, and you had to be completely focused to have those kind of notes. But the reverse is true. If you are, distracted and you're more interested in your cell phone or maybe talking to your buddy in class, well, listen, you're going to end up with grades like this. Okay, I made all those mistakes way back in the good old 1980s, except for the cell phone part. If I had a cell phone back then, I don't even think I would have have graduated. Cell phones are awesome, but they are massively distracting. So you're going to have to really be disciplined and put that thing away. The name of the game is focus. All right. Focus is the key to success in anything you do. And if you can't stay focused, you're going to have a tough time, being not only being successful in math, but anything you're going to try to do. So learn how to stay focused. And the best way to do that is to remain in an activity that's going to keep you on a straight and narrow. And that is note taking. But in the meantime, as you improve your notes, you can use my notes to study from. So those would include pre-algebra, algebra 1, geometry, algebra 2, and trigonometry. You can find links to those notes in the description of this video. Okay, so here is our lovely rational function. We need to kind of define what a rational function is, but of course, if you think you can graph this, sketch this thing out, or at least think about what you need to do here, kind of use this video as a little pop quiz, and I think that's even a better way to get the most out of this video, but we're going to get into it right now. Okay, so first of all, for those of you out there that are new to rational functions, let's just start getting some basic terminology down. And the first thing is asymptotes. We're going to need to know about asymptotes. That's a pretty fancy word. And, most people are like, asymptotes, what is that? And they're like, asymptotes. Well, asymptotes, they're an interesting thing, and we really need to understand them in terms of rational functions. But basically, let's just sketch out a line right here. I'm going to sketch out the line x equals 2. Okay, now recall x equals 2 is a vertical line. Okay, so here's 1, here's 2. And so x equals 2, I'm going to sketch this line out, but I'm going to sketch it out in terms of an asymptote. So what I'm going to do is I'm going to make a little dotted line. I'm not going to draw a solid line, just like this. So here is x equals 2, but I want to consider this line as an asymptote. So, but what does that mean? Okay, well, I'm going to tell you this right now. Let me erase this. Well, an asymptote is kind of like a border. It's a line. It's a reference line that we use when we're graphing. And what happens is whatever graph of your function, and it doesn't have to be a rational function. It could be all sorts of graphs have asymptotes. But let's say I have this graph and it's kind of going like this behavior. Okay. So I'm just sketching this like so. Let's just look at what's the behavior of this little graph. Well, it looks like it's kind of approaching this line x equals 2, and it's getting a little bit closer and a little bit closer. And that's exactly kind of what I'm trying to imply here. Yeah, this graph is going to get closer and closer to x equals 2, but if x equals 2 is an asymptote, this graph never crosses it, and it never touches it also, okay? So graphs never touch the asymptote and they never cross over it, okay? Then you're not dealing with an asymptote, you're dealing with something else. So an asymptote is kind of, again, it's a reference line where your graph is going to infinitely approach. So in other words, if we go out to infinity, way up over here, our graph is still going to just be a little bit off that asymptote, okay? So when we're talking about rational functions, you can have basically 3 different flavors of asymptotes. You can have vertical asymptotes, okay? You can have horizontal asymptotes. Matter of fact, you can have no asymptotes as well, and you can have oblique asymptotes. We're not going to talk about oblique asymptotes. They're not applicable for this particular problem because this requires a little bit more work in terms of polynomial division, etc., etc. But anyways, that's the first thing we need to understand is what an asymptote is. Okay, so we're going to have to find these asymptotes, whether we have horizontal or vertical asymptotes or oblique asymptotes. We're going to have to get those guys, put them on our little graph, and then we're going to have to take some additional steps so we can get the final graph. But before we move on, let's just define a rational function. So here, this is the second thing I have. So it's a function, f of x, and it's made up of 2 other functions, a numerator and denominator function, but both of these guys are polynomials. So by definition, a rational function is effectively like a fraction where the numerator and denominator are both polynomials. But that's basically the definition of a rational function. So again, my goal here is just to do a quick overview of rational functions, what they are, and for those of you that have never studied the graph of rational functions, hopefully now they got some basic idea of what asymptotes are, because we need to find these guys, and we're going to start working on that right now. Okay, so here is our general rational function. Now, again, you have basically 4 possibilities when it comes to asymptotes when you're sketching a rational function. So here is the general form of a rational function. We're going to be looking to see, hey, do we have vertical asymptotes? Do we have horizontal asymptotes? Do we have oblique asymptotes, or do we have no asymptotes? Okay, so these are all the things that we need to be considering. So let's go ahead and start looking at the first one, and that is vertical asymptotes. So the vertical asymptotes are going to be the zeros of the denominator. So that's just fancy language to say whatever polynomial is down there in the denominator of our rational function, we're going to set equal to 0, and those x solutions are going to be our vertical asymptotes. I'm going to show you exactly what this looks like here in a second. But this is the main idea of finding our vertical asymptotes. It's the zeros of the denominator. Now, how about horizontal asymptotes? Well, this is a little bit more involved. Okay, so there are three possibilities with horizontal asymptotes. Now, again, we can have no horizontal asymptotes, or we can have a couple other scenarios. Now, what you're going to be doing, I can more formally define this, but I don't think I need to do that. We're going to kind of keep this video a little informal. What we're going to be looking at is the degree, the power, okay? We're going to compare the power of the numerator and denominator polynomial. So I'm talking about the degree, the highest degree. Okay, let's take a look at this first one, okay? So when you look at the numerator and you look at the denominator, which polynomial has a higher degree? Okay, so hopefully most of you are like, oh, this is x to the third, this is x to the second. The numerator has a higher degree than the denominator. If that's the case in your rational function, there is no horizontal asymptote. Okay, so that's the rule. So hopefully most of you are like, okay, I get that, that's not that difficult. So let's look at the second scenario. What happens if your denominator now has a higher degree than the numerator? So this is 5x to the first. Now we have x squared down here. If that's the case, okay, the horizontal asymptote is the line y equals 0, which effectively is the x-axis. Okay, so the x-axis here, this guy, is going to be acting as the horizontal asymptote for that particular function's graph. All right, so again, not that difficult. We just have to go through these rules one by one. All right, let's take a look at this last scenario. What happens if, let me just put this back here. What happens if both the numerator and denominator have the same degree? So in this case, here we have 8x squared minus 2x, and here's 16x squared. Their highest powers are both 2. So it's like, well, what happens in that situation? Well, what happens is it's going to be the horizontal asymptote is going to be the line y equals, and you're going to use the leading coefficients here. You're going to use the 8 and the 16. Okay, of course, that's 1/2. But this line, y equals, whatever these leading coefficients are, is going to be the horizontal asymptote for rational functions where the degrees are the same. Okay, so if you can remember that, you're good to go. All right, so we're going to find the vertical asymptotes and horizontal asymptotes. Remember, there are problems where you have to find oblique asymptotes, but that's going to be beyond the scope of this video because we're going to have to do polynomial long division. But let's just kind of keep it simple with vertical and horizontal asymptotes, because this is probably going to be the majority of the problems you're going to be dealing with. Okay. All right, so let's go down and actually take a look at our problem. All right, so here is our function, g of x. It is, you can just see, we have, this is a polynomial and this is a polynomial. So we have a fraction with a numerator and denominator polynomial. So by definition, this is a rational function and we want to graph it. All right, so first things first, let's take a look at vertical asymptotes. So we're going to take this denominator again, and we're going to find the zeros of it. So we're just going to take this and set it equal to 0. And looking at this, x squared plus 2x minus 15, of course, I know all of you are up on your factoring skills. You'd be like, oh, that's x plus 5 times x minus 3. Now, if you don't know how to factor this, or you're like, wow, really, that's that? If you're kind of confused, then I would be, I wish I could put like a little siren here, okay, like a police siren, like, boop, 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 like a, alert, alert, and you need to go immediately improve your factoring skills, because factoring is critical to your success in algebra. Okay, so hopefully most of you are out there on this, but if you're struggling with factoring, you need to immediately start improving that. Okay, you can watch, I have a ton of videos on factoring in my algebra playlist, or maybe you just want to sign up for my algebra or algebra 2 course, because that's where I really get into rational functions and graphing, that kind of stuff. All right. So this factors this way. So now I can solve. I have x plus 5 times x minus 3. I can use the zero product property. I'm going to set each factor equal to 0 and solve. So I get x is equal to -5 and x equals 3. So those of you that are watching this video who are studying rational functions, this should be pretty easy to you. This should be like pretty basic algebra kind of stuff. But here, these lines, x equals -5 and x equals 3, okay, you're going to see here in a second, these are our vertical asymptotes. So we're going to sketch these out, okay, just 1 second. But now let's go and take a look at our horizontal asymptote situation. Okay, so now remember the rules here. I'm trying to determine, I'm looking at the degree of the numerator and the degree of the denominator. Remember that word degree means the highest power of these polynomials. So this is 2, this is 2, so that's a tie. So it's going to be what? Well, it's going to be y equals, and I'm looking at the coefficients here. Okay, so this is a 1. There's a 1x squared, so this is really just a 1, and this is a 1x squared down here, so this is really 1 over 1, right? We compare, we're going to create a fraction with this coefficient over this coefficient. 1 divided by 1, last time I checked, was 1. Okay, so y equals 1 is going to be our horizontal asymptote, and now we have our vertical asymptotes down here. X equals -5, x equals 3. Again, we have our horizontal asymptote. So let's put this on an XY graph, okay? All right, so we haven't even sketched this rational function. We've got to do all this work in advance. So here's x equals -5. This is a vertical asymptote, so that's a vertical line. Now notice that I have them as little dashed lines here. You want to make them kind of very subtle. Okay, you want to show them in your graph for your work, but you don't want them. They're definitely not solid lines. They're going to be dotted lines. Okay, and always work with pencil. Give yourself enough room, and if you have graph paper, all the better. So here's our other vertical asymptote. So you can label this stuff too, vertical asymptote, vertical asymptote. Okay, and that's going to be x equals 3. And then we have y equals 1, which is our horizontal asymptote. Okay, now one of the things that I kind of failed to mention, and let me go ahead and do so now, is that the graphs of rational functions have typically you're going to have, well, not typically, most part, they're going to have these, they're going to be branches. They're not going to connect like, like this, like a parabola or like a circle or something like that, or that's a ellipse. But they're going to be disconnected. They're going to have like branches like this. There's all kinds of situations you can have them like so, and there's going to be some sort of asymptote in there as well. All right, you could have things that look like this. Okay, so you're going to have what we call branches. Now, the thing here, now that I have my asymptote set up, there's all kinds of ways that this could turn out to be. Okay, I'm expecting some branches, and these are going to act as little borders between these branches. So I don't know if it's going to be like this and maybe like this or like this. That's one way this thing could look. Okay, so those are branches. It could look like this as well. It could look like maybe this, this, and this. We just don't know. Okay, so but we are going to have some branches in here. Now, how do I figure this out? Well, you're going to have to do some work, right? Unfortunately, what we're going to have to do, here's the x-axis, here's the y-axis. We're going to have to get a good old-fashioned xy table, and we're going to have to plot a bunch of points, okay? We're going to just start trying to determine the behavior and kind of start to see where these branches are forming. So we want to pick some x points in here, some x points in here. And as you get better at this, you don't need to pick so many, but you're going to need to pick at least a few to spread out to kind of see where these dots are kind of these points are kind of plot. So therefore you can kind of connect the dot. Okay, but you are expecting these kind of branches. Now I'm not doing all of these points because that would just make this video too long, but I'm going to give you a basic sense of what you have to do. Okay, now your points could look different than mine. It doesn't make a difference because you're going to see the behavior show up. So here is our rational function. So pick some easy x points, x values. Make sure they're spread across, enough here, right? You want to have some points, in this region and some points over in this region. You kind of want to see where these points are going to land. Are they going to land down here? Are they going to be like over here? Are they going to be over here? And it doesn't take many to start seeing the pattern and be like, oh, okay, this is like, well, I have 1, 2, 3. Oh, it must be like that. If it's kind of like 1, 2, a few like so, you're like, oh, it's going to be like in that manner. Because remember, rational functions, they have these branches, and within those branches are going to be smooth and continuous. But they're also going to approach those asymptotes. All right, so here's just a quick example of some points. So when x is 0, I plug in 0 right here. Okay, I do all this lovely math. You can see y is going to be equal to negative 1 over 15, negative 1/15. And then when I'll plug in for x is 1, plug in 1 right here, do all this math, I get negative 1/12. I'll plug in a 5. Okay, I can just go through and just get a bunch of points down here, and then you're going to plot these points. These are xy coordinates. Okay, so for example, this right here is the point 0, negative 1/15. Okay, and so you're going to have to connect the dots. These problems do take a bit of time. Okay, so if you're thinking this is a lot of work, well, you are correct. Okay, this is a decent amount of work to get these sketches down, but this is what's required. Okay. So now you're going to go ahead and fill this out. This table is completely not enough. You need more points here, but I just, I didn't want to go through and do too many points. Didn't want to make this video any longer than it needs to be, but you get the idea, right? You're going to have to pick some random points, and then we're going to put those points on the graph, and you'll start seeing the behavior. You'll be like, oh, okay, here's a point here, another point's here, points there, points here, 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 and one's going here, here. You kind of get the idea, and then it's just basically connect the dots. And now, obviously, if you want to make your graph more accurate, you make your XY table, okay, you use more points, okay? But over time, you'll start seeing, as long as you have few points, you just want to get a sketch. And I think most teachers will be pretty satisfied with your basic sketch. But show these branches, okay, again, you want to make sure that you're demonstrating that you're understanding of asymptotes, that you're not having your branch of your graph touch the asymptote, or you don't want to be showing it that it's going to run into the asymptote. Try to show the behavior that it's kind of approaching that asymptote. That's very, very important, okay? All right, so this is the basic sketch of that particular rational function, and if you got this right, if you're able to do this all by yourself, then I must give you a nice happy face with the good old-fashioned 1986 Mohawk, okay? Mohawks were still around 1986. They kind of started going, I would say, by 1990. I don't think too many people were wearing Mohawks, but a lot of people were wearing Mohawks in 1986, and that was a pretty cool thing. So, hey, listen, there you go. You get A plus, a 100% outstanding, okay? But again, how could you possibly learn how to do all this work? And this is a fairly medium level problem, okay? Sketching this rational function without taking notes, okay? You're not going to remember how to find the horizontal asymptotes, vertical asymptotes. I didn't even talk about oblique asymptotes. Again, when you start progressing in your math levels, or you might be able to get away with no note-taking with basic math. And even then, that's kind of questionable. But you start messing around with more advanced mathematics, algebra 1, algebra 2, there's just way too much information. So again, if you're struggling in math, you got to do your part. Okay, your part is to be paying attention, taking great notes, talking to your math teacher. But beyond that, okay, if you need more math help, there's tons of resources out there. Now, if you like this video, please consider smashing that like button. That helps me out. And if you like my teaching style, well, then listen, I would love nothing more to teach you mathematics. Please take advantage of all the videos on my channel. And matter of fact, while you're checking those out, please become a subscriber. Been on YouTube for 10 plus years, have over 1,000 videos, basic to advanced mathematics on my channel. Again, I'm posting new stuff all the time. So whether it's me or someone else, you have to go on the offense, take the initiative to improve your math skills. Okay, so everyone's different. Some people learn math, they have to not, work as hard as others. But listen, everyone could do well in math. Okay, so again, if you like my teaching style, please take advantage of my videos. And just as a reminder, though, my best math help will be within my math help program. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.